Hi, this is Margo. This is Monday, June 25th, 2018. And yesterday I started a show on talking about ozone. I did part 1 and they crashed my computer right as I was going to be showing you some more things on part 1. And I knew I was going to need to break the show up into 2 or 3 parts, but anyway, part 1 is up, and so it's a foundation on ozone, about what it is, why we need it, and that there's good ozone and bad ozone and what the difference is. And I'm going to continue where I left off, and I found out some more interesting information about ozone, so it might end up being 3 shows, but so we'll just go from there. And this is CAMS. This is the PLOTS website for global ozone forecast. Ozone, and we're just going to do a tiny review over what we went over yesterday. And CAMS is the Copernicus Atmosphere Monitoring Service, and they're out of the EU. So this is showing the levels around the world, and we have actual data back to June 21st through the 25th, and they're on UTC time, so they've already compiled the data for the 25th, and they're already into the 26th now. So when it's measured in total column, which is what this is, it's measured in DU, or Dobson units. And here's the graph down here, and these are Dobson units, and you can see the blue, and it's over the South Pole, you can see, and that's a thinning of the ozone layer, and it's down here, and it's about 225 Dobson units, and that's equivalent to a little over 2 millimeters of thickness of the ozone layer there. And that's what's called the ozone hole. It's over the South Pole in the winter, and ozone is depleted in cold weather and without sunlight, and then where there's sunlight in warm weather, ozone is created. And so good ozone is ozone in the upper atmosphere, and bad ozone is ozone in the lower atmosphere, toward closer to the earth. So let's run this movie. I was going to show you guys some of this yesterday, and you can see not only is it around the South Pole there, but there's a thinning right across the mid-latitudes. This is the equator. Right across the equator, you can see the ozone this is the good ozone that we're looking at. It's at the blue, and then this green is 250, and then the yellowy green is 225, and then the yellow with a little bit of green in it is 300, and they consider 300 DU as average, and it can go up higher, and ozone fluctuates just depending on where you are and what's going on in the atmosphere. And there are things that eat up the ozone layer too, and one of the things that eats it up is sulfur dioxide, and we have been seeing a lot of sulfur dioxide release recently from Hawaii over here, or up here, because of the volcanic activity that's been going on since the 1st of May, and there's a volcano that keeps emptying stuff out here in South Mexico. Then you had Guatemala going off, and then we had volcanic activity down here on the coast of Chile. We recently had volcanic activity on the Galapagos Islands. Hi, I'm back. I'm having technical difficulties. This is what happens. My software recording all of this stopped, so I recorded that first part, so hopefully I'll be able to put it together and make a movie. So anyway, I was at this part where I was showing that there had been some volcanic or sulfur dioxide coming up off the Galapagos Islands recently. I showed that in my last weather update video, and all of the volcanic gases and the ash and everything go up in the atmosphere and actually break down the ozone layer. So I don't know if that's what's causing this thinning around the middle part, and you can see that it goes all the way. See, it starts going across Africa, and then the Indian Ocean, and then Indonesia, and all those islands there, and it's actually touching that northern part of Australia and coming back across the Pacific Ocean. So this has scientists kind of worried. They're up in arms. And actually this next green color is also a thinning of the ozone layer, and that's at 220 DU, 250 DUs, and you can see that that's covering about the top half of Australia, and it's covering a lot of Africa. Most of South America is that thinner DU as well. So from about Central America going down to the mid-range of South America and the south part of Africa and a lot of Australia, it's really a lot thinner. And then you can also see the next level up at 275 is over the northern hemisphere. It's thinning out, and that's over the northern part of Africa, over all of Mexico, and a lot of the United States, and this part of the Middle East, and all of Saudi Arabia, all of India, and they actually have, it looks like a whole area. Look right there over, I'm thinking that's Tibet. I'm not really sure. We'd have to look at the World Atlas and see. But since it's summertime, there's plenty of ozone, it looks like, in the Arctic, and it's making ozone with the sunlight, and so that's a good thing. So if you haven't listened to part 1 of my ozone video yesterday that I did, I encourage everyone to go listen to that, and then you'll have a better idea of what we're talking about. We also looked at NASA's website on ozone, and I showed you that, and we looked at some maps and things, and when they talk about bad ozone, that's the ozone near the surface that's caused as a result of their thinking from vehicle and industrial emissions. And these are the levels that the Environmental Protection Agency has deemed to be safe. They're saying that an ozone layer levels greater than 70 parts per billion for 8 hours or longer is unhealthy. and they're saying the natural concentration of ozone in the surface is about 10 parts per billion. So whenever and people who are more sensitive and who have allergies and asthma and things like that, they can start reacting even at lower than the 70 parts per billion. That's for the average person, 70 parts per billion, but no longer than 8 hours. So anyway, and so it says the harmful effects can include throat and lung irritation or aggravation of asthma or emphysema. It can also cause cataracts and eye problems. It can cause lots of upper respiratory problems. I've got awful allergies today. I can barely talk, but I wanted to do what I could, trying to get the next part of my ozone video out. This is the ozone hole, and I was on sitemap and I clicked on bad ozone. There's a lot of information here about bad ozone, and it builds during the day when it heats up, and then it goes away when the sun goes down, because it's formed as a result of the sunlight interacting with these volatile organic compounds, or VOCs is what they're called, and NO2, nitrogen oxide, and NOx's is what they're called, and sunlight and heat, and that's what makes the bad ozone. Let's look at bad ozone now around the world. Now this is going to be shocking. And so we're going to switch. We're going to stay on the same view, but we're going to switch to surface level. And this is measured in parts per billion, as you can see. And CAM's changed down here. Now in this plots view, this chart is correct, but when you are on the charts view, when you go over here and you go from total column to surface level, well, that would crash. They don't want me to show you this. Their website is wrong. So when you go to see, they don't want me to show you what's wrong. Okay, you see down here, this is in DU, but when you go and change to, they're just not showing, they're not going to have any of that. What can I say? What can I say? Anyway, you'll figure it out. When you go to surface level in this charts view, they don't change this graph down here, and so but you're actually the colors and everything show up in parts per billion, like in this picture here, but over here it keeps showing up this chart for DU. So if you do it over here on the charts view, it's not correct. I mean, you can see it, but as far as interpreting, it's not correct. So let's just get our bearings and see what we're looking at here. I'm going to go back to the beginning of our forecast period, or this is actual data that we have from June 21st, and this is the world view. This low blue, this is very little, and so this is at the surface. So parts per billion, then so at 0, that means no, this light blue is no ozone at the surface. So that's like this color over here. over this northwest part of South America. So at 3 o'clock UTC time on June 21st, 2018, there was no surface level ozone that would be detected. Then this next blue is 10 parts per billion, and that's this color here, or over here in Brazil. And then this darker blue is 20 parts per billion over here, and that's what's over the majority of the ocean here. And then it hops up to green. This dark, like a forest green, is 40 parts per billion. Like, where's that dark green? And you can see the Antarctic it's got quite a bit of ozone. Well, at the surface, I would think it'd be less than that, but anyway. There's nothing down there to make ozone. Anyway, it just could be the way it is. I mean, the Antarctic, that's what I was looking at down there. Then up at the Arctic, there's very little surface ozone. But then we hop up into the greens, and we've got this forest green, then the mid green, like this olive green is 50, then this yellow green is 60, and then the cream colored pops up to 70. Now, that was the level that the EPA decided would be unsafe to breathe for after 8 hours for generally anybody. And you can see right over here, that's already at 70 parts per billion over parts of India and China and Asian countries. And then the gold is 80 parts per billion. And then it turns into a gold orange is 90. And then the orange is 100. And then red is 120. And the brick red is 150. And I'm assuming that 3 was a start of 300. I mean, yeah. I'm assuming that. I don't know. So let's run the movie. And I think you're going to find this quite interesting. I did. Now you can automatically see some coming up out of the ocean here. You can see North America. Now look over here across Saudi Arabia and the north part of Africa. And so when it's daytime, that's when these levels are going to go up, and so they're going to go higher in the chart. And then at nighttime they're going to go down, because this stuff is interacting with the sunlight. So I'm thinking that if they had cloud cover, it might not be as bad too. I don't know. But look at this big green area in the Pacific Ocean, just off the coast of the United States. And look how it just pops up all the way across the United States. Just pops up. And it actually goes into the gold and red on the east coast there. Now what I find curious, there are a few things I find curious here. First of all, easy things to explain are these higher levels over these areas with these densely populated areas like China with lots of cars and lots of pollution, and where it's so hot. And also where you've got oil refineries, like down here around Saudi Arabia, there's a lot of oil drilling and refineries and stuff. It's going to be interacting with that kind of stuff. Anything combustible things is gonna be interacting with that and making ozone. Now, what I find curious is Greenland, because what you see is, like, all across Canada looks pretty good up here. I mean, like Northwest Territories and the really northern part. The southern part of Canada, you can see, gets like this olive green, which is like 50 parts per billion. But the upper parts stay in these blue ranges, which are lower. But I just find it very curious why Greenland is so green, because there's nothing up there, and it's across the whole interior of Greenland, and that's where the glaciers are and the snow and everything. So I just don't understand that. That's curious to me. And I'm going to zoom in. Okay, we're zooming in. I'm going to start back at the beginning of the period. And when you're looking at, like, here's this green thing. I don't know if that's as a result of I don't know, volcano gases or what, why that's coming over here. But see how it goes up down here? That's the Los Angeles, Southern California, San Diego. That's all that area that's so highly populated. And then up through California. So that gets up into the cream colored, so that's 70 parts per billion. And it gets into the gold range as well. And then over on the East Coast, it gets into those ranges too. Now when you go up a little bit, I'm going to start this movie again, and I've really zoomed in, and I want you to be watching. This was very curious to me. I have no idea what's going on. I'm just going to show you the movie. It's making the movie. You see that? Popping up in Canada, and it's popping up over here too. This is the Northwest Territories. You see that? And here it is again and again. This is the data. What can I say? I have no clue what this is, but it's in the red zone. And it's repeating. It's periodically repeating, like on a schedule. And I plugged these coordinates into Google Earth, and that's like in the middle of nowhere. And this stuff over here, that's in Saskatchewan, where there's nothing. And over here where it's popping up, it's in these mountains. But I'm telling you, there is something strange going on. There's something going on in Canada. Let's go back. Now we're into the forecast period. Let's go back to the beginning. I want everyone to see all this again. This flipped me out. I mean, I was flipping out this morning when I was looking at this. It just didn't make sense. And then I did a search to see, look at that popping up here. Now this is Reindeer Lake. I found that on Google Earth. And these are some mountains. And so here's Reindeer Lake, but then we got something going on over here. So I don't know. And the time frames when this is popping up. Now, I looked it up. I'm pausing the movie. These Northwest Territories are on Mountain Time, and so they're 6 hours earlier than UTC time. So it started, I think, around the 23rd. The first popping up. This is the kind of thing Guy McPherson would say, stop looking. Now see, look at that. Now these guys are on Central Time, so they'd be minus 5 hours. So that'd be around 10 in the morning on the 21st. So that's, okay, there it is, popping up. Almost like it's venting or something coming up out of the ground. And so minus 5 would be 1 p.m. on the 21st. And then that's 3 hours more. So there you go. Now it's going away, and then it's starting up here, and this is Mountain Time, so minus 6 hours, so that's 9 p.m. on the 21st. This is nighttime, so there's no sunlight interacting to make this stuff. This is not from sun. Watch. Okay, here watch this right up here. It's going to start up again. Okay, we're into June 22nd, 15 UTC time. Okay, see? It's popping up. 18. So 6 hours earlier would be 12. So 12 noon. And then that's at 3 p.m. Then that's at 6 p.m. because it's at 0 UTC time on 6/23. So that's at 6 p.m. And see, it came up there at 6 p.m. too. And it's still there, very strong. That's at 9 p.m. on the 22nd. And now it's going away. And that's at midnight. And then it cycles through. I'm just clicking, and each click is 3 hours. And now we're on the 23rd at 18, which is 12 p.m., which is the same time we saw it the day before. Look, and there it is at 3 p.m., 6 p.m., 9 p.m., it's going away. And there it is at midnight. Now we're in the 24th. Okay, here it starts again at 18, which is 12 noon. So it's like some kind of activity going on that's actually creating or releasing ozone in these mountains. And they're like rocky mountains. It doesn't even look like lush green mountains. So it's a pattern. So there it is at 6 p.m., then 9 p.m., and then midnight, and so forth. And so we're on the 25th, and now it's popping up over here at 12 noon, and so forth. I think it's going into the forecast period now. So I don't know. I don't know what this is, but it's kind of flipping me out. So if you want to see where these places are on Google Earth, we can, and now, well, okay, it doesn't want to work. Google Earth, they don't want me to show you. I'll sneak up on them another time and show you that. So that was the strangest thing I saw. And I'm sure if I dug deeper, so those things popping up in Canada, and then the level of like that green over Greenland, constant. It's like this constant. It doesn't even move. I mean, look. It just doesn't move. It just sits there, and it changes different colors of green. But it's like I can't explain it. I just